Hello and welcome to Math200 Statistics online here at Cañada College. My name is Lapuz. In this video, we will take a look at problem number 2 from section homework 10.3. We have the director of the student services at a college, and they're interested in whether women are just as likely to attend orientation as men before they begin their coursework. Sample is given from freshmen, and they were asked what their gender is and whether they attended orientation, and here are the results. Okay, they're asking what could be concluded here at the 0.10 significance level. So for the study, we are actually going to be testing two proportions, and with two proportions, or with proportions in general, but two proportions, to proportion test, we're actually going to be using the normal distribution, and that's the Z test. And so on the calculator, you would probably look at this as a 2-prop Z test, and we're going to, however, use Google Sheets. So the big question was whether women are just as likely to attend orientation as men. So we are looking, this person is interested in checking to see if the proportions are the same. So that would be more or less your claim or your question, and the proportion is going to be denoted by P. And so the proportion for one sample, the first sample, let's say for women, and we actually need to remake this table because this table gives the yes and no answers for men. We are interested in the yes answers for women and men, and the yes answers were 377 for women and 379 for men, which looks like it's pretty close to being equal. But then we have to determine the sample size. Now, they gave us the people who said no, but we actually want the sample size. So what we need to do is we need to add the total number of women to get our N. So this would be, I believe it's 639. And we could let our calculator do this work, but let's see if we could do it before that. So this is a 3, 11, 12, so 723. We can double check that later. Okay, back to our proposed hypothesis. Are just as likely to say that means that if this is population 1 and this is population 2, we want to know if population 1 is generally equal to population 2. Okay, so that would, because it has the condition of equality, this will serve as our null hypothesis. So P1 equals P2, and so the alternative hypothesis would be the not equal to symbol, which is also going to prompt us to think about the tail. This is going to be a two-tail test. Okay, all right, so I generally wanted a red pen for your answers. Okay, from here we want to fill in our test statistics. So remember that this is a Z test statistic, and then we're going to find our test statistic, our p-value, and then from there we're going to decide if it's bigger than or less than, and then whether we're going to reject or fail to reject. So now we move to our calculator, and our calculator or our Google Sheets has information, and they want us to fill in the proportion that said yes for the population. So for population 1, there's 377. Population 2, there's 379. Now, just to make sure I added correctly, I'm actually going to fill in an addition here. So I'll say equals, oops, this is going to be equal to 377 plus 262, and I get 369 there, which is good. And then for the second one, I'll get 379 plus 344, and that's 723. Okay. All right, so this is a two-tailed test, so I will use the 0 for the marker for the two-tail. And here in this particular calculator, they did the calculation for the proportion of population 1, so that's 377 divided by 639, so that's about a 0.589. And then for population 2, they get 0.52. So again, it looks fairly close, but is it really that close statistically, which with such a high sample size, maybe it is, maybe it isn't. Okay. The pooled proportion is needed for our calculation, and the pooled proportion is calculated here. And that pooled proportion is actually the sum of the successes divided by the sum of the sample sizes. Okay, and that happens to be 0.55. Okay. So here the test statistic is given by the formula, and we got a test statistic of 2.4378. So we'll go ahead and mark that, 2.4378. And then our p-value is 0.01477 or 78. So it's 0.01478. Okay, now compared to the significance level, it looks like our p-value is smaller. PV is less than our alpha, and with such a small p-value, we will reject the null hypothesis. And remember, the null hypothesis was saying that the two proportions are equal, and they came close. They look like they would be equal, but statistically we still had to reject that. So in rejecting this, we need to find our correct statement. So we rejected the null hypothesis, and so we have to say there probably is a difference. So not as likely to attend this, so you could probably say there is a difference here. There is a difference because we rejected the statement that said that they were the same. All right, so let's see which one has that statistically significant. So there's insufficient evidence to conclude the population is different. So it's not different is what they're saying. I don't think that's it. There's sufficient evidence to conclude that the population with 10 orientation is different. So there is a difference. So I think this one might be it. It has the significance level, and there's evidence to conclude that there's a difference. So let's hold off and think that that's probably it, but let's check the others. Statistically significant, so there is a sufficient evidence to conclude that they're. So whenever they include the data, that's really not what we want, so let's cross that out as well. And then the last one, the results statistically significant. There is statistically significant evidence to conclude that the population proportion is the same. So we're not saying it's the same, we're saying that there's a difference, so it can't be that last one either. So this must be our choice. All right, so that's it. This is the hypothesis test for two proportions, and I hope that helps.